Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about general characteristics of carbohydrate. You know friend, the term carbohydrate is derived from the French term hydrate the carbone. Hydrate the carbon. Compound composed of carbon, hydrogen and oxygen. Empirical formula CH2O Olen, where N is equal to 5, then C5H10O5. Not all hydrocarbohydrates have this empirical formula. If you talk about the deoxysugar and amino sugar, they are not like the empirical formula. Carbohydrates are the most abundant compound found in nature. So friend, general characteristic of carbohydrate. They have large number of hydroxyl group. You know the hydroxyl group OH. So polyhydroxyl. In addition, they may contain an aldehyde CHO group, polyhydroxyaldehyde, or a keto group, polyhydroxyketone. Their derivatives may also contain nitrogen, phosphorus, or sulfur. Hydroxy groups, you can see carbon contains hydroxy group, aldehyde group, and keto group. Now, friends, functions of carbohydrate. First, source of energy, especially for brain cells and red blood cells. Intermediate, in the biosynthesis of other basic biochemical entities like fats and protein. Associated with other entities such as glycosides, vitamins, and antibiotics. From a structural tissue in plants and in microorganisms. Form the structural tissue and participate in biological transport, cell-cell recognitions, activation of growth factor of the immune system. So friends, classification of carbohydrate. Classification of carbohydrate is very important. First one, monosaccharides. Second one, oligosaccharide. And then polysaccharide or glycans. What does it mean of monosaccharide? Monoses or glycoses, trioses, tetroses, and pentoses and hexoses. Oligosaccharide, di, tri, tetra, penta, up to 9 or 10. Most important are the disaccharides. Homopolysaccharide and heteropolysaccharide. So, what does meaning of monosaccharide? Also known as simple sugar. Simple sugar means monosaccharide. Classified either by the number of carbon atom or by the nature of functional group, aldoses or ketosis. Most of the carbohydrates, 99%, are straight chain compounds. D-glyceraldehyde is the simplest of the aldoses, aldotriose. All other sugars have the ending OSE, glucose, galactose, ribose, and lactose. My friend, monosaccharide nomenclature. According to number of carbons they contain in their backbone structure. It is variable prefix followed by the suffix OS. Trioses 3 carbon, tetroses 4 carbon, pentoses 5 carbon, hexoses 6 carbon, and heptoses 7 carbon. According to nature of the reactive group, aldose sugar, that is glyceraldehyde or ketose sugar, example dihydroxy acetone, depending on the presence of aldehyde or keto groups. You see D-glyceraldehyde and dihydroxyacetone. So friends, monosaccharide classifications on the basis of carbon. Triose, tetrose, pentose, hexose, and nosose. So examples of triose glyceraldehyde: tetrose, erythrose, pentose, ribose, and hexose, glucose, fructose. Now you can see aldose, aldotriose, aldotetrose, aldopentose, aldohexose. So N denotes the number of asymmetric carbon. So aldose, ketose sugar, ketose, ketotriose, ketotetrose, ketopentose, ketohexose. N denotes the number of asymmetric carbon. Now, what does it mean? What is asymmetric carbon? My friend, it is the carbon atom that is attached to 4 different groups. All monosaccharides have it except dihydroxyacetone. Different isomers are possible based on the presence of number of asymmetric carbon atoms. My friend, isomerism in monosaccharide. D and L isomerism, the designations of a sugar isomers as the D form of its mirror image, as the L form is determined by comparison of its special relationship to the parent compound of the carbohydrate. The 3-carbon sugar glyceraldehyde, also called reference sugar. The orientation of the hydrogen in hydroxyl group around the carbon atom adjacent to the terminal primary alcohol carbon as carbon 5 in glucose determine whether the sugar belongs to D or N series. When OH is on the right side, the sugar is D. When it is on left, it is N. So D and L isomers of glyceraldehyde. Now friend, isomers of monosaccharide D and L. Most of monosaccharide occurring in mammals are D sugar, and the enzyme responsible for the metabolism are specific for this configuration. Simple monosaccharide with 4, 5, 6, and 7 carbon atom have multiple asymmetric carbon, and they exist as diisomers, isomers that are not mirror images of each other. Some sugar naturally occurring in the L form, L-arabinose and A-xylulose, uronic acid pathway, it is subsequently covered to its D form. So D and L isomer of fructose, you can see in enantiomers, mirror image configuration. So optical isomerism, the presence of a symmetric carbon atom, also refers optical activity on the compound. When a beam of plane polarized light is passed through a solution of optical isomers, it rotates either to the right dextrorotatory or the left levorotatory. The direction of rotation of polarized light is independent of the stereochemistry of the sugar, so it may be designated D minus D plus N minus or N. For example, the naturally occurring form of fructose is the D minus S. In solution, glucose is dextrorotatory, and glucose solution are sometimes known as dextrose. So this is the polarimetry, measurement of optical activity in chiral or asymmetric molecule using plane polarized light is called polarimetry. The measurement of optical activity is done by an instrument called polarimeter. Now friend, a specific rotation of various carbohydrate at 20 degrees Celsius. D glucose plus 52.7, D fructose minus 92.4, D galactose 18.2, L arabinose 104.5, D mannose 14.2, D xylose 18.8, lactose 55.4, sucrose 66.5, maltose 130.4, invert sugar 19.8 minus, and dextrine plus 195. So what is the isomers of monosaccharide? So epimers. Very important word. Epimer carbons are the middle asymmetric carbon other than the subterminal one related to D and L form. The difference in orientation of OH group around only one of these epimer carbon will produce epimers. Isomers differ as a result of variation in configuration of the OH and H on carbon atom. 2, 3 and 4 of glucose are known as epimers. Biologically, the most important epimer of glucose are mannose and galactose, formed by the epimerization at carbon 2 and carbon 4 respectively. Mannose and galactose are not epimers of each other as they differ in configuration around 2 carbon atoms. So, you can see epimers of glucose at carbon 4. So, isomer of monosaccharide aldoses. It is not clearly looking, but you can see aldotetrose, aldopentose, and aldosose. Isomer of ketoses. So, isomers of monosaccharide, pyranose and furanose ring structure. You can see the pyrene and furan. You know, friends, about the enamers. The ring structure of an aldose is a hemiacetal. Hemiacetal is very important. You know the acetal, you know the hemi. Hemi word is very important, since it is formed by combination of aldehyde and alcohol group. Similarly, the ring structure of ketose is hemiacetal. The ring can open and reclose, allowing the rotation to occur around the carbon, bearing the reactive carbonyl groups, yielding 2 possible configurations, alpha and beta, of the hemiacetal. And hemiacetal, the carbon about which this rotation occurs is called anomeric carbon, and also stereoisomers are called enamers. The crystalline glucose is alpha D glucopyranose. You see cyclic Fischer projections of alpha D glucose, Haworth projection of alpha D glucose. Enamers, when drawn in the Haworth projections, the alpha configuration places the hydroxyl toward downward while the beta is reversed. So enamers, when drawn in the Fischer projection, the alpha configuration places the hydroxyl attached to the anomeric carbon to the right of the ring, while beta is reversed. Now, I will talk about the mutarotations. Carbohydrate can change spontaneously between alpha and beta configuration through the formation of intermediate open chain, and this will lead to the process known as mutarotation, and this is gradual change of a specific optical rotation of sugar. So, alpha D glucose converted into beta D glucose through the equilibrated solutions. So, friends, I think this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.